Okay, welcome to this lecture of numerical analysis. In this lecture, we will study the Taylor's method, which is a numerical method of solution of ordinary differential equations. So, given a differential equation of this form, dy by dx is equal to f of x y with some initial condition y of x naught equal to y naught. So, this kind of a problem is known as an initial value problem. So, given an initial value problem, IVP is shortly denoted by initial value problem. Given an initial value problem like this, dy by dx is equal to f of x y, where y of x naught is equal to y naught. And we are required to find the solution. So how do we use the Taylor's method now? Now, assuming that if y of x is the solution, if y of x is the solution of this initial value problem, then the Taylor series of y of x about the point x0, is defined as we take the Taylor series like this: y of x is equal to y naught plus x minus x naught divided by, in fact, 1 factorial into y dash of x naught, then plus x minus x naught whole square divided by 2 factorial into y double dash of x naught, then plus so on. Similarly, the third term will be x minus x naught whole cube divided by 3 factorial y triple dash of x naught. Okay, now here in this Taylor series for y of x, we use the y of x naught equal to y naught, which is used here. Then here we are given y dash, which is equal to f of x y. We take its derivative y dash and use the point x naught to obtain the value of y dash of x naught and so on. So then using y dash is equal to f of x y, which is our given problem of ordinary differential equations, and we are given that y of x naught is equal to y naught. Then using this yields the solution. Okay, so now in order to understand this properly, let's move towards an exercise. So we will take the first exercise as if dy by dx is equal to x minus y square. We shall write this as x minus y square, where y of 0 is equal to 1. We are required to find y of 0.1 using Taylor series, using Taylor's method. Or we can simply write using Taylor series or using Taylor's method, using Taylor series. Okay, now let's move towards the solution. So what we are given here, we are given the function f of x y, which is equal to x minus y square. We are given x0, which is equal to 0, and given we are y0, which is equal to 1. So we are given y of 0 is equal to 1, that is x0 is equal to 0, and y0 is equal to 1. Now, assuming that y of x is the solution, so according to Taylor's method, if y of x is the solution, then we need to explain y of x about this x0. Then Taylor series for y of x about x equal to 0 is given as, y of x, this is equal to y naught plus x minus 0 divided by 1 factorial y dash of 0, y dash of x0 or y dash of 0 here, then x minus 0 whole square divided by 2 factorial, then y double dash of 0, then plus x minus 0 whole cube divided by 3 factorial y triple dash of 0 plus so. Okay, now this can be written as, this is y naught plus x y dash of 0 plus, sorry, this seems to be second derivative, so we shall write this properly as this single derivative, then plus x square divided by 2 factorial y double dash of 0 plus x cube divided by 3 factorial y triple dash of 0 plus so on. Now we just need to evaluate what is this y of 0 is given to be equal to 1. We need to evaluate what is y dash of 0, y double dash of 0, y triple dash of 0, and so on. So now let's compute them. So now y of 0 is given to be equal to 1 and y dash is equal to x minus y square. Therefore, thus y dash of 0 is equal to 0 minus y square at 0. So this is equal to, now 0 is same as 0, we don't need to write that. But now y of 0 is equal to 1, so this is equal to minus 1 square. So that is equal to minus 1. That means y dash of 0 is equal to minus 1. Now next, y double dash of x, sorry, y dash of x. Okay, so y double dash of x, this is equal to now derivative of y dash of x. So this will be equal to 1 minus, now derivative of y square, that is 2y, into derivative of y, that is y dash. This implies y double dash at 0. This is equal to 1 minus 2 into y of 0 into y dash of 0. So this is equal to 1 minus 2. Now y of 0, as we know, it is equal to 1 and y dash of 0 is equal to minus 1. So this combined gives us 3. Similarly, we can compute y triple dash of x, y triple dash of x. Now derivative of y double dash of x is equal to 1 as derivative 0 minus 2y. Now derivative of y dash, it is y double dash, then minus 2y dash into derivative of y is again y dash, so this becomes 2y dash whole square. So hence this y triple dash at 0, this is equal to minus 2y of 0 into y double dash of 0 minus 2 times y dash of 0 whole square. So this becomes minus 2. Now y of 0 is 1. Now y double dash of 0 is computed in the previous step, that is equal to 3 minus 2 times y dash of 0, that is equal to minus 1 whole square. So this becomes minus 6 minus 2, which is equal to minus 8. Similarly, we can compute y fourth derivative at 0 and so on. Now using all these values here, so we shall call this equation as equation number 1. Using these values in 1, using these values in equation 1 yields, we will get the value of y of x. So then y of x becomes equal to, first of all, we will have y0 there, and y0, as we know, that's equal to 1 plus x into y dash of 0. Y dash of 0 is computed here, that is equal to minus 1 plus x square divided by 2 factorial into y double dash of 0, that is equal to 3, then plus x cube divided by 3 factorial, y triple dash of 0, that is equal to minus 8, then plus so on. So finally we can write this as 1 minus x plus, so this becomes 3 divided by 2 x square, then this becomes minus 8 by 6, so that can be written as 4 by 3 x cube plus so on. So this is our solution, which is actually a series solution obtained by Taylor series method. Now in our question we were asked to find y dash y of 0.1, so hence we can easily evaluate y of 0.1. Now this is equal to 1 minus 0.1 plus 3 divided by 2 into 0.1 whole square minus 4 divided by 3 into 0.1 whole cube plus so on. Then using the calculator we will get this value. We will only take the first 4 terms into consideration and write this is approximately equal to, I have done already using the calculator, so this becomes 0.91367 using only these first 4 terms. Thank you.